Now this is the last video of this unit number 4. That is the example of flexible coupling, or you could say the numerical on flexible coupling. This is the numerical that is design a bush pin type flexible coupling. We need to design it, and the power is given to us, RPM is given to us, overall torque is 20%. That means 1.2 times the service factor is given to us. The material properties are given to us for shaft and all these things. Let's write down the given data here first. So we write it down here properly. Then find out the torque. The mean torque we need to find out with the help of formula. It is P into 60 by 2 pi n. The mean torque is 318.3 Newton meter. So the maximum torque is mean torque into 1.2. It is 382 Newton meter. So now based on this, the diameter of shaft, it is 40 mm. Okay. So based on diameter of shaft, we can find out the number of bolts with the help of this formula. That is diameter of pin is equal to small d1 equal to 0.5 times small d upon root of n, which is 8.2 mm. But in order to allow for bending stress induced to the compressibility of the rubber bush, the diameter d1 should not be less than 20 mm. So it is taken as 20 mm. So d1 is 20. So small d2, that is the larger diameter, that is you can the enlarged portion of a brass bush of thickness 2 mm, and all these things we can consider. So for that it is 40 mm. So flange will have 40 mm at left side, and right side it is 20 mm. Now that capital D1 will be what? 2 times this small d plus d2 plus 2 into 6. So we will get 132 mm here. So capital D1 is 132 mm. So L and load, we can find out load is equal to PB d2 into L. 32 times L. Torque is equal to what? This load into N into capital D1 by 2. So we put the values in terms of L, you will get a value. So here we can find it out with the help of these terms. With the help of this relation, we get the value of L. So put this value of L here, you will get W, that is 1024 Newton. Now the direct shear stress to pure torsion in the coupling is what? Tau is equal to W by pi by 4 d1 square. So in this way. In coupling, just remember we need to find out the torque first, then design of hub and all these things. But here in bush pin coupling, first we need to design a bush and pin. After that only you are going to shift to the other part. So first we find out the torque, and after that we are designing for the pin now. So we find out the load. Now direct stresses we are checking, and even the bending stresses we are checking with the help of this formula. Z we know now. So sigma is equal to m upon z, 27.4 Newton per m square. Based on this, maximum principal stress is half sigma plus square root of sigma square plus 4 tau square. So all these stresses are under the limit. That means design is safe here. So now we can proceed further. So for hub, outer diameter is 2 times small d, 80 mm, L is 60 mm. Then hub design check can be done. So shear stress is 4.04, which is less than 15, so it is safe. Key, same table, I am not going to show the table again. Here also sigma ck is equal to 2 times tau k, that's why it's a square key. Okay, whenever this condition is there, that means a square key is there. So W and T both are same here. Put the values and check design for key. So design for key, we check it and we get the answer safe. So now design for flange, tau TF is equal to 20 mm, and we can check the maximum torque transmitted by this. It is 1.9, which is less than 15 megapascal, so it is safe here. So we can say this thing that design of flexible coupling is safe here. So this is how we are going to design a flexible coupling. So it is clear now. I hope you get all the points here. If you have any query, you can contact me. So thank you.